Alright, so this is problem number 3 for the extra credit of exam 2, and this is problem number 14 from the exam, and it reads as follows. For the reaction 2A plus B yields 3C, the following data was obtained. And it tells us that in experiment 1, we had 1 molar concentration of A and 1 molar concentration of B, and it gave us a rate of 5 times 10 to the second. And then in the second experiment, 2 molars of A and then 1 molar of B, and it gives us a rate of 10 times 10 to the second, and so on and so forth. So in order to find what is the rate of the reaction, the question that it's asking us, what is the rate of the action, what we have to do is, well, basically see the trend that is going on. To do this, first we have to remember that if it's zero order, the change in the concentration of the reactant is not in any correlation related to the rate. If it is first order, the change of the concentration of the reactant is the same as the change in the rate. So let's say here, let's say the concentration was triple, then over here the concentration was triple, then it's first order. So that's going to be first order. And if it's second order, the concentration, the rate is going to be the concentration squared. So let's say here they gave us that the change was like 3, and then over here the change is going to be 9, because it's going to be the square of the concentration. Alright, so now we're going to actually see what's going on here. In order to find the relationship, first we have to see what's going on in each reactant. So first we're going to go with A. In order to find the change in the concentration of A, we have to find where where B, the concentration of B is constant. That would be experiment 1 and 2. So in experiment 1 and 2, B is both 1 molar. So we can see how the concentration of A directly affects the rate. So here, from 1 to 2, the concentration of A is doubled. And then over here in the rate, from rate of experiment 1 to rate of experiment 2, the rate is also doubled. So if they're both doubled, then that means this is first order. So A is first order. Now we're going to look at B. For B, same thing, we have to find one where the concentration of A is constant. So in experiment 2 and 3, concentration of A is constant. Let me change my ink so it'll be easier to see really quick. Sorry about that. Alright, so the concentration of A in experiment 2 and 3 is constant, and in B it changes. So we can see the direct correlation of the change in concentration of B compared to the rate. So in B, from experiment 2 to experiment 3, the concentration is doubled. And then over here in the rate, in comparison from experiment 2 to experiment 3, the rate is quadrupled. So since it is quadrupled, we can say that it is the change in the concentration of B squared. So that's going to be second order. So B is going to be second order. So our rate of reaction is going to look like K, A, first order, B, second order, or K, A, B, second order, and that's going to be D. That's our answer. Thank you.